Hello students, good morning. Today we are going to start our lecture number 4 of module 4. Okay, up to the previous lecture we studied McLeod gauge, Pirani gauge and penning gauge. Okay, in that penning gauge is comes under the category of ionization gauge, and in that cold cathode ionization gauge. Okay, and in today's lecture we are going to start our hot cathode gauge and BA gauge, which is also comes under the category of ionization gauges. See, ionization gauge is a device that is used to measure vacuum in the hot cathode type. A column of a gas is introduced into which a potential difference V is applied with free electron in the space. This causes the electron with a charge E to acquire a kinetic energy VE if the pressure range of the gas in the column goes below a certain limit called the critical pressure, then corresponding to a voltage larger than the critical voltage VC, the energy VE may be high enough to initiate ionization, and positive ions will be produced when the electrons collide with the gas molecules. Now see here what we are doing actually in ionization gauges. In ionization gauge, we are providing external potential difference, and due to that external potential there is a creation of electron and ion pairs. Okay, and first we are set the some limit of pressure, and when that pressure is goes down to that limit of pressure, then that pressure we are calling critical pressure. Okay, and the corresponding voltage is called an critical voltage. Now the third point is that here I am wrote the some critical voltages for some gases. First, for cesium critical voltage is 3.88 volt, for helium 24.58, and for the diatomic gases like nitrogen, hydrogen, this is roughly 15 volt. Okay, and this is also called as ionization potential, and at this potential the pressure is also an important, or we are measuring the corresponding pressure. Continues here. At very low pressures during the intervals of time for transient from the cathode to plate in a vacuum chamber, more than one collision is unlikely for an electron. Then for a fixed accelerating potential V greater than Vc, the number of positive ions formed would vary linearly with the value of pressure. Thus, a determination of the rate of production of positive ions for a given electron current should give a measure of pressure. See here, at very low pressure during the interval of time for transit from the cathode to plate in a vacuum chamber, more than one collision is unlikely for an electron. Then for a fixed accelerating potential V greater than Vc, the number of positive ions formed would vary linearly with the value of pressure. As potential increases greater than critical potential or critical voltage, then obviously pressure value is also linearly vary with the applying potential. Thus, a determination of the rate of production of positive ions for a given electron current should give a measure of pressure. Okay, this is very important point. That means as we are providing the external potential V, due to there is a creation of electron and positive ions, and due to that there is a creation of current. Okay, corresponding to that current we are measuring the pressure. See here working. The construction of a cathode type hot cathode type ionization gauge consists of a basic vacuum triode. Okay, see here the figure of an external control type hot cathode gauge is shown below. This is actually in ionization gauge there is a cold cathode, hot cathode. Okay, and in that hot cathode also there is a external control hot cathode and internal control hot cathode. In external control hot cathode I am explaining, and after that internal control hot cathode gauge, in that BA gauge I am going to explain after that. Okay, or I will explain after that. First here, the grid is maintained at a large positive potential with respect to the cathode ion plates. Okay, and the plate is a negative potential with respect to the cathode. This method is also known as the external control type ionization gauge, as the positive ion collector is external to the electron collector grid with reference to the cathode. The positive ions available between the grid and the cathode will attract grid and the cathode be drawn by the cathode, and those between the grid and the plate will be collected by the plate. See here, this is a working of the external hot cathode type gauge. See here, which is important. As we know, the always grid is at large potential as compared to the cathode and plate. Okay, the plate is also a negative potential with respect to the cathode. Okay, now see here, this method is also known as external control type ionization gauge, as the positive ion collector is external to electron collector grid with reference to the cathode. Okay, the positive ions available between the grid and the cathode, okay, and be drawn by the which those between the grid and the plate will be collected by the plate. First of all, as we are giving the external potential V, the cathode emits the electrons, okay, and that emitted electron will generate electron and positive ions pairs, okay. In that electron are attracted to the grid which is at higher potential as compared to the cathode, and the positive ions will attract to the plate which is at more negative potential as compared to the cathode, and there is a measurement of the current due to of that positive ions. Okay. Next one, BA gauge. See here, the internal control type is shown below. Here the grid is a positive ion collector and the plate is the electron collector. Okay, in the previous one what happened, in the previous one grid is the electron collector and the plate is positive ion collector, but here is the interchange. Here is the grid is the positive ion collector and plate is the just electron collector. See here, one of the most popularly used hot filament gauge for the industrial application is nothing but the Baird Alpert's type filament gauge. It consists of a helical grid with a potential plus 150 volt. This huge potential attract the electrons and thus causes gas ionization at minus 30 volts. The gas ions are attracted to the central ion collector, thus producing an ion current of 100 milliampere. This value is then fed to the electronic system to amplify and display. Same as I explained in the previous one is also that when there is a creation of positive ions and electron, in that electron are attracted towards the grid and positive ions are attracted toward the plates which is at the negative potential compared to the cathode, and there is a current drop due to that positive ions. Okay, similarly here also, as there is a 150 volt for that grid, this is very much potential as compared to cathode, then that electrons are attracted towards that, and there is the ionization of maximum gases. Okay, continues here. The hot cathode gauge, the hot cathode ionization gauge is useful in measuring the total pressure of all the gases present in the system. The biggest advantage of this device is its very small response time. This is because of the device's small inertia. The device is used for pressure measurement between the ranges of 10 to the power minus 8 to 10 to the power minus 3 torr with an output current varying between 10 to the power minus 9 to 10 to the power minus 4 ampere. But this range depends on the gas, other things remaining constant. Whether the pressure is higher than 10 to the power minus, where the pressure is higher than 10 to the power minus 3 torr, the positive ions make a greater impact on the cathode to heat it up and ultimately destroy it. At pressure ranges below 10 to the power minus 8 torr in external control type, the electrons impact over the grid and radiates soft X-rays, which results in the production of the electrons from the plates and secondary emission. This can be passing high this electron produced will be same order as that of positive ion current in the plate circuits and thus neutralizes this current. Thus the internal control type is known to be better option to measure pressure as low as 10 to the power minus 3 torr, minus 9 torr. When the cathode remains at very temperatures, the gaseous matter present inside may reset with the filament or with the themselves, particularly at different pressure stages. This may causes the device to produce wrong outputs and may also affect the cathode life. During extreme condition of high temperature and low pressures, the presence of any gases inside the device will be forcefully released, thus causing the pressure to increase. Thus the electrodes have to be properly treated before use. This can be done only by passing this current. This can be done only by passing high currents through the electrodes, especially the filaments and the grid, and by high frequency heating of the plates. To overcome these problems, the cold cathode type ionization gauge also used many times. Okay, student. Up to this lecture, we studied all the gauges. Okay, and the remaining part is low temperature techniques. Okay, that will studied we in the next lecture. Thank you.